Hello, people of the internet watching later. I forgot to start the recording. Okay, well, whatever. Nobody watches these things anyway. All right, zeros. Zeros means setting the whole thing equal to 0. So if I set the whole thing equal to 0, zero product property says I get to set the individual pieces equal to 0. So either that equals 0. If that equals 0, what do you get? 4, right? Let me just write some scratch work here, zeros. So if x minus 4 squared equals 0, then x is 4. Or if x minus 2 equals 0, then x is 2. Or if x plus 2 equals 0, then x is negative 2. And that's it, right? Those are the 3 zeros for this thing. One from setting each factor equal to 0. The leading coefficient, negative 2, that counts as a factor also, but it can't be 0, right? Because it's just the number 2. So we've got a degree 4 thing with 1, 2, 3 zeros, but that's okay, right? The number of zeros can be less. There is one thing here that might jump out at you. What do you notice about what just happened there? One of these things is not like the others, right? The square on that one. Now, it doesn't change anything in terms of solving, because to get rid of the square, you do a square root. Square root of 0 is 0. So like it doesn't affect anything there, right? But it does mean that in the factored form of this, right? Go back to the imagining multiplying the whole thing out. There are 2 factors of x minus 4 in that expansion, right? That means that that one counts twice, right? It sort of counts double. So this, number of zeros is up to the degree thing. If I count them that way, this one counts twice. So 1, 2, 3, 4. My fingers don't match what I'm saying, but 2, 3, 4 zeros. If I count that's called the multiplicity of the zeros. This one counts 2 times because of that square. So I count it twice. 1, 2, 3, 4, and then that actually matches the degree. Okay. It also does something else. This thing having multiplicity like multiple, right? Same root. Just kind of organize stuff a little bit here. The multiplicity is the number of times that factor shows up. So this one has multiplicity 2 because of the square. The other 2, well, their factors only show up 1 time, right? They're sort of an implied 1 as an exponent. So their multiplicities are 1. Again, if I add those 2 plus 1 plus 1, I get the degree 4. Multiplicity, again, is just a count of what happens. But there's an interesting thing that happens. If we look at the graph of this thing, let me rearrange so that we can see, kind of a pretty version of it. The zeros were negative 2 and 2 and 4, right? What happens at negative 2? Crosses the x-axis, right? Well, I mean, that's what we said ought to happen, right? We called it an x-intercept. There it is, crossing the x-axis. There, let me change the color on this thing, maybe. Nope, you can't tell anyway. It all just looks the same. Maybe that's better. Crosses the x-axis. If I kind of look at it nearby there, I zoomed in a little bit, just kind of looks like a straight line right there. What happens at 2? Same thing, right? I mean, it crosses the x-axis just like we said it ought to. What's different about 4, though? It doesn't cross. It intersects, but it doesn't cross. It bounces off. It touches the axis and turns around. The fancy math word is it's tangent to the x-axis. There's that one point they have in common. And other than that, I could keep zooming in all day and I would always see just kind of a little gap, you know, next door to that, right? That it's sort of falling away from it on both sides, but there's that one point where they intersect.
This is the power to the 4 function, right?
Well, even lower than that, it looks kind of like a parabola, right? It's got the same shape nearby, locally, right? Not the whole thing, but if I zoom in and kind of just focus right there, it pretty much looks like a parabola. Well, parabolas are quadratic, which means they have a square term, which means they're degree 2, and the multiplicity, if you want, it's kind of like the degree for just that part of it, just that term, was 2. So what it does there is it behaves like a degree 2 thing. Somewhere in the directions for this problem, I said something like, you know, describe what happens at each 0. The behavior of each of these things, this one bounces off. It touches and turns around. It changes direction or its tangent as it's intersecting. I'm just going to say it bounces off. The other two, the graph crosses through the axis there. Okay, so if I want to sketch this thing, I need to put that all together. I've got the ends on there already that they're facing down. At 4, we're going to sort of bounce off the axis. At 2 and at -2, we're just going to go straight through. So I'm just going to try to draw the thing in. It's a polynomial, which means it's all one continuous piece and it's just kind of nice and smooth, right? So no like really sharp changes or whatever. So I'm just going to kind of draw this thing in, bouncing off there, and then ending up pointing down. There's one other thing that we could find pretty easily, and that would be the y-intercept. Y-intercept you can always get by just plugging in 0. So take your function, replace all the x's with 0, and then figure out what that is. -2 times 16, 32, negative 64 positive, and 120. I think it's 128. Oh yeah, 128 and 1, 2, 3, 4 negatives, so positive. Yeah. So that's this. If we needed it for something, right? That's how you would find the y-intercept. Okay, so leading term tells me a bunch of stuff, right? The degree, the leading coefficient, that tells me the end behavior. Also tells me what to expect when I go to find zeros and their multiplicities and everything, because the degree being 4 means the sort of total multiplicity, like the sum of the multiplicities should also be 4. Those should match. I get the zeros from the factors, right? Each factor gives a 0 when you set it equal to 0. And then the multiplicity tells me about the behavior there. Okay, do we have any questions about any of that? Let's take a couple of minutes then, and you give B a shot. Do the same kind of thing, right? So figure out what the leading term would look like, the degree, what that means about the end behavior, find the zeros, put it all together. Of course, you can look at a graph, right? But look for how all that information is kind of sitting there. No problem. Yep. Yep. Yeah, if it helps you to, think of that, that way, like the parentheses don't really do anything. But for some reason, making it look more like the other things helps some people. You could even, if you want to think of this as x minus 0 or x plus 0 or whatever, like that's what that factor is. Obviously, we don't, normally write that because it's kind of redundant, but if that helps you sort of think about things, then by all means, go ahead. I'll put that in a different color. There we go. Okay, so what is the leading term? We multiply everything out, we get x squared times x. So x to the 5th. And just for emphasis, I'm going to write positive x to the 5th. Again, just to emphasize the leading coefficient being positive, because that's going to tell me something about which way the thing faces, right? What's the degree then? 5. If the degree is 5 and the leading term is positive, then what do the ends look like? They point in opposite directions, right? So it's always about, negatives canceling in pairs. So if it's odd, that means you're going to get, the two sides being opposite, right? Odd degree, ends are going to go in opposite directions and end up pointing up. So they're going to look like that, right? Okay. While we're here, let's just find the y-intercept real quick too. If I plug in 0, what do you get? If you plug in 0, let me get this stuff out of here. If I let x be 0, you get 0 times anything, who cares, right? You get 0, yeah. So this would be 0 squared times 2 squared times -3, but who cares? It's 0. Okay. So there's a point at 0, 0. And whatever else happens, the ends are gonna look like that. Now, what are the zeros? The x-intercepts. If I take this whole thing, set it equal to 0, and then solve by splitting factors up, right? We get that x squared could be 0, which would mean that x is 0. Yep. 0 with a multiplicity of 2 because that one shows up twice.
Well, 2 with a negative 2.
-2 with multiplicity
Of 2.
2.
Then 3.
And 3 with multiplicity 1 because that one shows up one time, right? No exponent written, so it's sort of the understood or implied 1. So 3 with multiplicity 1. Okay. I'm just going to rearrange these so they're in the same order they would show up on the graph, right? Because my brain can't handle the other way around. I stared at the thing for like 5 minutes in the last class. Multiplicity gives us, again, like a qualitative thing about what it does, right? And how it behaves. Multiplicity being even means it's going to bounce off. Multiplicity being odd means it's going to cross. And for pretty much the same like sign reason as what happens with the end behavior, right? So it's pretty much the same idea. If the multiplicity is 2, then that means on either side of this, just like right next to it, right, locally, the ends are going to go in the same direction, right? So either both up or both down, which means it's bouncing off.
So how do you tell when it bounces or if it crosses?
If the multiplicity is even or odd.
Okay. So
Yeah.
if it's multiplicity, that means it bounces. and
Right. So the
odd.
multiplicity, you can, again, pretty much think about it the same as like degree. It's like the degree for that piece. If this is even, then locally, the two pieces moving away from it are going to do the same thing. If they're doing the same thing, it means it's kind of bouncing off. So the same thing happens for this one. And then for 1, odd. So again, locally moving away from that 0, they're going to go in opposite directions, which means it's crossing. For the most part, we're really only going to see stuff where the multiplicity is either 1 or 2, just kind of like, reinforce this idea. If it's something higher, like if it was 6, the idea is the same, that it bounces off. What's going to happen is that it's just going to kind of flatten out a little bit first, but still like bounce off. So, if 2 looks like that, then 4, 6, 8, whatever, might just look a little more kind of like drawn out, right, of where it actually crosses. For odd ones, if the multiplicity is higher, like say the multiplicity was 3, well, an example of a cubic that has 1, 0 that has multiplicity 3, right? And what does it do at its intercept? Kind of flattens out as it crosses, right? It slows down, it crosses, and starts speeding up as it moves away, right? It does this kind of like wiggle, flatten out thing. That's what will happen if you had, somewhere in the middle of the thing, whatever else, but x plus 2 cubed. So you have a multiplicity 3 intercept. What happens is that it's just going to flatten out there in addition to whatever else happens. Okay. And again, if you want to think about it as like, if I zoomed in on that point, it's going to look like that kind of thing, right? Okay, so I need to draw this -2, 0, and 3. This one's going to bounce off. This one's going to bounce off. This one's going to cross straight through. So something like that. Notice I didn't, apart from finding the y-intercept, I didn't do anything to figure out like how tall these are, what the y values are, anything like that. I'm just looking for the end behavior. And then, basically like this little kind of strip near the x-axis, what happens, right? Crossing or bouncing off in the right places. Okay. So that kind of puts a lot of these skills together. The next couple of days, we're going to look more at solving equations. So we'll be talking about finding zeros, some more there, and some of the techniques we can use for that. We can also do this same thing, but from the other direction, right? The flip side of this. Here's a graph. Here's a graph kind of scaled a little better so we can, get a good look at it.
Oh, that's the school equation.
This is a different thing. This is a graph of some polynomial. So what I would tell you on a question like this is that this is a graph of a polynomial. We can assume that everything is what it appears to be. So we can assume the degree is as small as it could possibly be. The multiplicities are as small as they could possibly be. The zeros are where they look like they are. The leading term is positive or negative, but it's either plus or minus 1. So it's not like the leading coefficient is 7, and I'm expecting you to just guess that, right? So things are what they appear to be. How can we figure out, what information can we take from this graph to be able to basically write down the function in factored form like we just did?
So basically, I would say it's a leading coefficient is probably like x equals 4 or something like that.
Okay, why?
Because it intersects the x-axis 4 times. Well, not intersects, but it touches the x-axis.
Okay.
4 times.
1, 2, 3, 4 zeros, right?
Yeah.
Okay, there are 4 zeros. What are they? This is -5, this is -3, -5, -3, 1, and 4. What are their multiplicities? Again, assuming things are as small as they could possibly be, what do I need to look for to figure out the multiplicities?
So the first one, -5 is going to be 1.
What happens at -5?
It bounces off.
It bounces off, which means the multiplicity's got to be even. If I'm assuming it's as small as possible, that would mean 2. Okay, -3 goes through, so 1 at 1
Yep.
goes through at 4 goes through, so 1. Okay, so just by the behavior, what happens there, right? Okay, the total multiplicity then, 2 plus 1 plus 1 plus 1 is 5. I still can't count on my fingers while I say things. It's 5. So the degree is 5. If we're assuming everything's as small as it could possibly be and things are what they look like they are, then the degree 2 plus 1 plus 1 plus 1 is 5. Does that match what the end behavior does? What do the ends do?
They're opposite.
They're going in opposite directions, which tells me that the degree is odd and 5 is an odd number. So, okay, great. That all matches, right? What else do we need to be able to write this down? Is the leading coefficient positive or negative? Negative. How do you know? Yep. Okay. So let's write it down then. Y equals negative. Each zero gets a factor, and each factor has, a power like according to its multiplicity, right? So x being -5 being a 0 means that we get a factor that looks like x plus 5. Its multiplicity is 2, so squared. Okay, what are the other factors? X plus 3, x minus 1, x minus 4. And those all just show up one time, right? First power. Yeah. None of those things are particularly difficult to do, right? Like it's all sitting there. It's a matter of keeping straight, like what each thing is, where it comes from, where you need to look, right? So this is a like very conceptually rich question that if you understand what's going on, you can pretty much just look at it and write down all the answers. And it's like free, it's not like you're gonna get, you're gonna make some mistake in the middle of doing some drawn out thing and that throws it off. And, it's not like that. This is difficult then, but in like a different way, right? So there's plenty of, practice stuff in the homework. We'll do some more in class. At some point, we'll probably just start Thursday by doing another, thing like this. But yeah, take a look at homework stuff. We're done, quote unquote, with 4.1 and 3. So go do some homework stuff. If there are things we need to talk about on Thursday, we can do that. Y'all have a good day. I'll see you then.